Hi you guys, here is a short video on the practice test for the Unit 1. During the pandemic, I know I have another video up with a different practice test, but here we go for this one. I'll try to go as fast as we can through some of these. Don't know if we need to really get into what a solid, liquid, and gas is, but could be fun. All right, so here we go. Milk is going to be a liquid at room temperature. Oxygen is a gas at room temperature. Pencil is a solid. Shampoo is a liquid. Ice cubes is a solid. Oil is a liquid. Water vapor is a gas. And helium, like in a balloon, that's also a gas. For the next set, you've got tell whether it's a chemical or a physical change. Chemical change would be one that's like irreversible. And physical change would be one that is like reversible or undoable in theory. Okay, like I know that it's not easy to put you break a glass and put the whole thing back together again. It's probably not like really practical to do, but in theory it's possible. So this is going to be a physical change. Hammering one together, physical change, you can undo that. Rusting bicycle, that's going to be a chemical change. You can't undo the rust. It has changed the metal forever. Melting butter, the key here is melting, that you can, once it cools again, it's going to be solid butter, and so this is a physical change. Oh no. So physical change for melting butter. Separating sand from gravel is also physical change. Bleaching your hair, it does come back, but it doesn't come back because it changes back. It comes back because new hair grows in that is your original color. So this is a chemical change. Same with frying an egg. You can't get the original egg back. So that is one reason that it's a chemical change. Okay, evidence is a chemical change. This is on your quiz. I'm asking you again on the practice test. I think I'm asked you on the review. Expect to know these 4 things for the test on Monday or Tuesday. The evidence is a chemical change. We have the first one is color change. Then we have energy transfer. Something gets hot or cold. We also have bubbles or gas is formed. Oops, that's neither one of those words. And finally, you have that a solid is formed. Like this means like you're mixing two, like let's say liquids together, and they form a solid at the bottom. All right, so those are the 4 evidences of chemical change. For substance, mixture, element or compound, remember that a substance can only be these 2 things, and a mixture can only be those 2 things, okay? There is no mixture that's an element or a compound. You get the idea? That's how the words work here. So sand is going to be a mixture. There's no chemical formula for sand. And every time you grab a handful of sand, it's completely different, so it's heterogeneous. Salt has a chemical formula. Any chemical formula is going to be a pure substance. And since the chemical formula is not on the periodic table, right, there's no box for NaCl, so it's going to be a compound. I suppose I don't need to write the whole thing out. Gold, on the other hand, there is a spot for on the periodic table, so it's an element. Oxygen, same thing. It's a pure substance. It has a chemical formula, and so it's an element because there's a box for oxygen on the periodic table. Coffee, there's no chemical formula for coffee. It's a mixture. And, I mean, if we're this gets kind of ambiguous with the wording, but as long as it's just black coffee with nothing else in it, it's most likely going to be a homogeneous mixture. All right, so there you go. Compounds, mixtures, substance. That's how all the words go together. All right, for the math problems, we're not breaking any new information here. You've seen these problems a bunch of times, so you can expect to see some more of them on the quiz or test on Monday or Tuesday. If there's particles is the same thing as like asking molecules. So how many particles are there in a 1.24 gram sample of cadmium? You take your 1.24 grams of cadmium. And since we're going from particles to, from grams to particles, we know it's going to be a 2-step problem. The molar mass of cadmium is where it would go down here, right? 1 mole for the 2-step problems, always 1 mole there and always 1 mole here. But I need to cancel grams, so I'm going to have grams down there at the bottom of the first parenthesis. The molar mass of cadmium is 112.4 grams. I just canceled out grams. And I'm going to cancel out moles here, which is great, but I need to have my answer in particles, or molecules, so this is going to be particles here. And I know that there are 6.02 times 10 to the 23rd particles in 1 mole. So if you take 1.24 times 6.02 times 10 to the 23rd and divide by 112.4, you end up with 6.64 times 10 to the 21st particles. All right, next problem. A student needs 15 grams of ethanol for an experiment. If the density of ethanol is 0.789 grams per milliliter, how many milliliters of ethanol are needed? So this is a density problem. You can use the density triangle. Density equals mass over volume, like that. And in this problem, I am solving for volume, how many milliliters. So I'm going to cover up the V. And what's left is mass over density. So I take my mass, which is 15 grams, and I divide by the density, which is 0.789 grams per milliliter, and end up with about 19.01 milliliters for my answer. For number 3, how many grams are in a 3.18 mole sample of nickel 2 chloride? There's the formula for nickel 2 chloride. I'm going from grams to moles. It's a one-step problem. Sorry, going from moles to grams. 3.18 moles. And we know you gotta add the molar mass of nickel chloride. We say 1 mole would go down here, and the molar mass in grams would go on top. So to add up the molar mass of nickel chloride, nickel is, oh man, I can't find it. It's not, oh, there it is, 58.7, and 2 chlorines is 71. When you add them together, you get 129.7, 129.7 grams or so. Oops, I already have grams. This is bad. How will I erase it? Oh, okay, this is terrible. Nailed it. And so this time you're just going to multiply 3.18 by 129.7. You end up with 412.45 grams. All right, number 4 is a specific heat problem. What's the final temperature of a 20-gram sample of aluminum? This is the specific heat, that accepts 500 joules of heat at 22 degrees Celsius. For this one, I'm going to just rearrange it for the MEMS. Here's the equation: Q equals MC final minus initial temp. I want to get final temp by itself. First thing I do is divide both sides by M and C. So I'd have Q over M times C equals final minus initial, and then both sides. I kind of want this one by itself, so then what I do is I add Ti to both sides. So the final equation would be that final temperature equals Q over M times C plus initial temperature. So you can plug all those numbers in right now from the problem. The Q is the energy, which is 500 joules. The M is the mass, which is 20 grams. Specific heat of the sample is 0.897. And I'm going to do all this first. Actually, I'm going to do this first. And then I'm going to add the initial temp at the end, which was 22 degrees Celsius. So 500 divided by 20 divided by 0.897 plus 22 ends up being about 49.87 degrees Celsius for your final temperature. Finally, a simple problem. What's the molar mass of sodium sulfate? That would be 2 times sodium, which is 23, plus 1 sulfur, so 32, plus 4 oxygen, 4 times 16. So you add those together. People have been confused. Like this is, you want to do those things first. Add them all together, and you get about 142 grams per mole. There you go. Pretty good sample of the kinds of things you see on the test for Unit 1 during a pandemic. This has been a fun video to share with you. Best of luck to everyone, and we'll see you real soon. Okay, bye.